Very good. My name is Bill Brennan. I am CEO of a distribution company in San Diego, California, by the name of Unlimited Controls. Been in the industry for a long time, 30 plus years. My original move into the controls and instrumentation industry was with Industrial Controls, based in central New Jersey. Went to work for them in January of 1989. Within 2 to 3 years, I was tasked with opening up a New York City branch office for Industrial Controls, which I did. And actually, that office in mid-Manhattan on 29th Street between 7th and 8th is still there, many years later. So I've been in the business a long time. I cut my teeth in the Northeast here, and it's been a fun ride, to be honest. I enjoy my work very much. Just to kind of touch base on what I'd like to speak about this morning is I've just given you a little bit of an introduction on me. Want to discuss the market that I've seen across North America, really. We'll get into the available technologies, pluses and minuses of both, and then any questions that you guys might have at the end. Let's get started. First, I want to talk about the market a bit. I typically read through this. This is an important piece to this puzzle. Category 15 specifies safe design, construction, installation, and operation of refrigerant systems. The standards apply to the design, construction, test, installation, operation, and inspection of mechanical and absorption refrigerant systems, including heat pump systems used in stationary applications. The safety classification of R410A, we're focusing on R410A because that is a vast majority of the applications, not all of them, but the vast majority that we're seeing in the field. Standard 34 is Group 1 R410A, meaning non-toxic and non-flammable. It has no ozone depletion potential, and it meets the stringent mandates of the Montreal Protocol and the US EPA. However, due to the ability to displace oxygen, they're referencing another ASHRAE standard. They've established a maximum refrigerant concentration limit to 26 pounds per 1,000 square feet of room volume for occupied spaces. For institutional occupancies, the limit is reduced to 50%, 13 pounds per 1,000 square feet. Since the indoor unit fan coils are in direct contact with the air being distributed, this system is classified as a direct system. According to Standard 15, by definition, a direct system is also classified as a high probability system, meaning that a leak of refrigerant can potentially enter into an occupied space. You've got a discharge coil in the room that has refrigerant gas, high tonnage, high pressure. It's not hot or cold water in there anymore. It's refrigerant gas. I was made aware of this application back in June of 2017. First I've ever heard of it. Hilton was building a 220-room hotel on Ash Street here in downtown San Diego. It was one of their Carte hotels, the little funky rooms that they have. And I got a referral from Honeywell Analytics saying, we don't have anything to handle this application, Bill. Why don't you call these guys, see what's going on? So I got a handle on what they were looking for, and had a meeting with the construction group down at the job site. I gave them the options that were available at the time. Back rack manufacturers, the MVR 300, which is one solution. MSA had a solution, another type of technology. So there were two available. The one with using photoacoustic technology, which comes from MSA, was $700. And the back rack MVR 300, which was available, was much more moderately priced. So for that project, they wound up using 220 of the back rack units because that was the only thing available. During the discussion I had with the construction group, I told them of the nature of the detector and what was required by the end user, the owner of the building or the maintenance staff of the building. Because of the nature of the technology, which is metal oxide semiconductor, that detector requires calibration every 6 months and then a replacement of the sensor head every 2 to 3 years. So the cost of ownership for the building management company is substantial. Is spending a lot of time making sure this thing is functioning. The guys in the construction meeting, especially the lead, leaned in on a table and started yelling at me. This is the only thing available, Bill. This is what we have to use. There's nothing else available in the market to monitor this with something that's not a piece of crap, is basically what he was saying. And at that point, I thought about that, and the light bulb went off over my head. It really did. He said, he's right. He's exactly right. There should be a better solution than what's available. So that's kind of where I started back in June of 2017. I reached out to a few different manufacturers around the planet. I found 2 companies that I engaged with initially. I finally settled on one company that had the much better technology than was available currently. I have developed a partnership with an Italian gas detection company by the name of Sensitron. They have a full portfolio of gas detection equipment that they're selling around the world, and they were a good source to at least talk to. So we worked through the application. They did have the technology that we needed in order to move forward and have a better option. So that's where it started. A bunch of construction guys from Hilton literally screaming and cursing at me for having to put the back rack unit in. So I want to touch on sensor technologies here a little bit. Introduction to the 2 types of sensors being used. Excuse me. Predominant sensing technologies: non-dispersive infrared, NDIR, and metal oxide semiconductor. The metal oxide semiconductor change of resistance as a result in a change of an absorbed oxygen concentration. Let me just repeat that. The MOS type gas sensors change resistance as a result of a change in absorbed oxygen concentration. If this is used adequately, one can detect reducing gases. The absorbed oxygen formed in clean air will be consumed on contact with the gas, the resulting decrease in resistance being used to estimate the concentration of gas. The sensor recovers to the original level of resistance when the carbon monoxide or the whatever gas you're monitoring is off. Such a detection mechanism is operated in tin dioxide-based gas sensors. The problem that I had with the metal oxide semiconductor is that definition. It is looking for something other than the target gas. In this case, refrigerant gas, R410A or whatever is currently being in use. So it's not really, it's not effective technology. It's older technology. It goes through a couple chemical reactions. I don't know that we really need to get into that too much, but bottom line is the metal oxide semiconductor, the electrochemical type, degrade over time. The initial cost is low, but the cost of ownership for the people responsible for maintaining that system is a nightmare in my book. So here's a basic photo illustration of what the detector looks like. This is the technology that Bacharach is using in their MVR 300. What I was able to do is partner with this Italian manufacturer, who is one of the premier manufacturers of gas detection equipment, especially sensors. The detector that I have developed with the help of the Italian engineers is using NDIR, non-dispersive infrared gas sensor. When infrared radiation interacts with gas molecules, infrared light is absorbed by the gas molecules at a particular wavelength, causing vibration of the gas molecules. Non-dispersive infrared gas sensors detect decrease in transmitted infrared light, which is in proportion to the gas concentration. The key difference between this new technology is it is looking at only the target gas. It is not affected by oxygen levels or any other gas other than the target gas. It is calibrated specifically, in this case, for R410A. Non-dispersive gas sensor consists of an infrared source, a detector, optical filter, gas cell, and electronics for signal processing. The single light source, dual wavelength type gas sensor has 2 detectors and 2 optical filters of different wavelengths, which are in place in front of each detector. The infrared light that is absorbed by the target gas passes through the active filter with a particular bandwidth for the detection of the target gas. Infrared light does not interact with the target gas as it passes through the reference filter. The difference between transmitted light intensities in these 2 bandwidths is converted into gas concentration. The dual wavelength sensor ensures stable measurements for a long period of operation, as the aging effects of the light source or the gas cell are automatically compensated by output signals at the reference wavelength. Absorption of infrared light occurs at the IR energy, i.e. wavelength, specific to the target gas, meaning high selectivity to a specific gas. That's a huge point with these detectors. This is the most distinctive feature of non-dispersive infrared gas sensor. Another feature is that exposure to high concentration of the target gas for a prolonged time period would not result in irreversible sensitivity drift, they say in principle. I'd use a little stronger word. Main advantage is the low cost of ownership. The Bacharach needs to be calibrated every 6 months, and then the sensor needs to be replaced every 2 to 3 years. So you got a mechanic in a 400-room hotel, and all he is doing is calibrating, setting up those detectors. It's just a maintenance nightmare. A couple important points to consider. Particular considerations need to be the composition of the refrigerant gas, especially those that contain fluorine or bromine or chlorine molecules, because these molecules will block the surface of the metal oxide semiconductor and catalytic sensing beads options, with a drastic reduction in sensitivity, or in case of strong leakage, total loss of sensitivity. This point needs to be well described in the instruction manual, and the right technology needs to be selected according to the refrigerant gas being detected. In case of gases containing fluorine, chlorine molecules, if metal oxide semiconductor or a catalytic sensor is used, it shall be mandatory to advise the user to check and recalibrate detector very often, and in case an alarm has been generated by a strong amount of leakage, to replace the sensor. Accuracy in the long term depends on the nature of the sensing technology as well. The IR technology, being optical, has no degradation and remains stable, no degradation and remains stable, while the metal oxide semiconductor increased their sensitivity over time, and the catalytic sensor, as well as the electrochemical cells that used to be used, lose sensitivity. This means that with a metal oxide semiconductor sensor, we will have an alarm too early, even if no gas is present, which means that this technology requires frequent maintenance calibrations. With the catalytic sensor, we may have an alarm at a threshold higher than the planned one. And also for this type, it needs regular maintenance to get the alarm at the initial preset value. A lot of maintenance with the older style technology, and I refer to the older style because that was the only thing available at the time that I started this search in 2017. I've broken down the various types of sensor technology available. Electrochemical cells, not really in use too much. I don't run into it very much at all. It looks like it's not a bad choice for NH3. Metal oxide semiconductor, again, a breakthrough. It's okay, at some levels. Increase sensitivity with A2Ls and some of the other options. Not really, can't use it for a CO2 application. Again, the biggest problem for me is the amount of maintenance required using that type of sensor. Same thing with the catalytic, the old style Wheatstone bridge loses sensitivity over time. Poison problem, I'm not quite sure what they're referring to there. Non-dispersive infrared using optical technology is suitable for most applications. We're not using it on CO2 or NH3, but the rest of the applications listed, the various types of refrigerants, it is a very reliable option and a long-lasting option. And a little bit more of a breakdown just between the IR and the metal oxide semiconductor. Initial infrared cost is more expensive. There's no doubt about it. But we incur very little maintenance cost with the new technology versus the calibration every 6 months and the replacement every 2 to 3 years that BACRAC recommends on the metal oxide semiconductor. We're listing 5 to 7 years in this particular text in terms of longevity. I honestly feel that this sensor in a clean, dry environment is going to last 10 or 15 years. It is stable. I can't print that, but I know it's possible. I know it's possible. 10 years minimum. Very stable. It's going to last. The gas sensitivity, a little bit more, we can do more with the IR sensors than with the metal oxide semiconductor. The detection limit response time is a little quicker. Operating temperature, minus 40 to 60 C, kind of covers all application. Metal oxide semiconductor a little bit higher. Temperature dependence, plus or minus 3%, full scale range. On an IR detector, and varies with the manufacturer and the model you're using. If you're using metal oxide semiconductor, accuracy plus or minus 2% of full scale. Metal oxide semiconductor is at about 5% plus or minus. This is a key point too, I believe. The interfering agents, something that could give you a false reading. Gases with the same absorption spectrum in terms of the IR detector, and a lot of stray gases create problems using the metal oxide semiconductor, ethanol, silicones, etc. You can see the list there. False triggering agents, none involved with the non-dispersive infrared solution. Metal oxide semiconductor is affected by all kinds of stuff. Gasoline, diesel, propane exhaust, fume from solvents, paints, and cleansers. little bit of technical data here just to kind of break it out. Again, lifetime with the various types of availability, 2 to 3 on the electrochemical, metal oxide semiconductor, 3 to 5 catalytic, Wheatstone bridge. I don't see that, but again, 3 to 5. Beautiful thing about the stable non-dispersive infrared sensor is the lifespan. We fully expect in a standard refrigerant application for this sensor to last 10 to 15 years. I pulled this off of out of a textbook too. So that's not something I'm just winging. Again, maintenance periods, and to me, the cost of ownership to the building manager, to the chief engineer, is critical to my thinking. I've been dealing with end users in buildings for almost 30 years now, and I know I kind of know what's involved with that at some level. And if you can reduce maintenance issues for a chief engineer, he's just going to love you forever. That's the way I view that. Again, lifetime, little lower with a CO2 application. Again, 10 to 15 years on any refrigerants currently in use. We recommend a bump test every 12 to 14 months. Bring a bottle of gas in, hose a cup, just to actuate the sensor to make sure it's operating. I have a demo demo case here that I'll show you a little bit more about the functionality of the device. But again, some good detail on the types of sensor. That's the extent of my presentation. What I'd like to do, if this works, is show you guys the demo unit that I've got sitting here. We can kind of go through that and answer any questions that you may have.
Hey, Bill, really quick. Looks like we did have one question come in that I feel like we can answer now.
Yeah.
Will this work? Are these going to be set up to work with the new 513A or other potential refrigerants that could be coming in the future?
Yes, they are. And I'm going to turn my video on here real quick. You guys see me?
Yep, we see.
The nature of our detector is really pretty advanced. I have in my hand the non-dispersive infrared sensor head that's being manufactured in Italy. What we've done is we've paired this sensor head with a microprocessor. You can see the microprocessor board on the bottom. With that board, I can have this sensor head calibrated to any refrigerant gas currently in use, and a lot of those being contemplated. I have another sensor head for A2L applications, which it seems to be the way things are heading. But this is the key to the detector, is the nature of the sensor with an onboard microprocessor. It allows us at the factory. It's just a matter of dialing in the wavelength of the target gas, and we can do any gas currently in use, and those being contemplated. I'm pretty proud of that.
One other question we got for you here.
Please.
The hotel application, I believe it's the Hilton you were talking about, where the VRF was installed. Were the sensors at every evaporator? And if so, were there any audio visual alarms? Sounds like you're going to get into a little bit of the alarms coming up, but.
Yeah, the application over at the Hilton Carthay Hotel was per the Hilton spec. And when I started this, there was only one company that had any kind of specification, and that was Hilton. Really simple is all they're looking for. At 1,000 parts per million, they wanted a visual indication on the detector. They want an LED. They want a light, basically that's showing an issue. At 2,000 parts per million, they want that first visual indication to turn red. So we want a red alarm visual indication In this case, we pull in two. I have three onboard relays, but we're using two of the relays that close when it reaches the concentration level. Relays out to in the case of the demo I have behind here, and I'll show you guys this in a minute. You wire the relay outputs back to the room controller and room controller output to the BMS. You can also interface with a third-party interface to drop the information back into the the VRF system, the controller, the control of the VRF system. Bottom line. So there's a couple ways to do that. Any more questions? Anything else?
Yeah, so it looks like you got into the building management system and the alarm. So we covered that. There's a couple other questions on where these are installed. A couple questions about being installed in ductwork or individual rooms. So can you touch on how we want to install these in the rooms?
Absolutely can. And again, this comes from Hilton. This was really designed with those guys in mind when I started this. We want to locate it between 12 and 18 inches from the floor, as close to the discharge of the fan coil as possible.
And that the reason we want to install them close to the floor is because the refrigerant is heavier than air, so it's going to be sitting down below.
Correct. It's displacing oxygen, so you want that alarm, before it gets up to your knees. If you're in that room or up to the height of the bed. The thing about these systems, and I'm sure I have VRF experts on the line here. I am no VRF expert. I'm a pretty good controls guy, but as far as the full system, I don't, I understand the nature of it, but we're looking at high tonnage and high pressure. And if you get a pinhole leak in one of those discharge coils, from my point of view, that's gonna fill up that room pretty quickly. High tonnage, high pressure, which is part of the application here, part of the problem.
Perfect, thank you. One other one we have coming in, speaking on the mounting, are these going in a J-box? Are they surf mounted enclosure?
I'm gonna pop my camera back on. I have an answer.
Okay, so we're getting a couple questions. I'm gonna let you proceed, go a little bit more, and then in the 10 or 15 minutes, I'll stop you again and we'll start to answer more questions.
No, very good. I want to show you what I have here. Box detector comes in a small box. When you open it up, here is the detector. If you guys haven't seen it, included in the box with this is a little plastic bottle with a magnet in it. It has a magnet in this box. Two-piece enclosure. It's a two-piece plastic enclosure. Sensor head here. This particular unit is low voltage, so you would wire it here. This up here is the Modbus RTU output, soon to be changed to back rack. Within 6 months, this will, or not back rack, what am I saying? BACnet, this digital output will be BACnet capable. So a lot of people seem to be really positive about that. 3 relays on this side of the board here. And there's the sensor microprocessor head as it's set up. This is my detector is designed to fit in a 2-gang junction box. What I have found is guys that originally contracted with back rack, and then they found that they can't deliver for 26 weeks. I've developed a backing plate. Back rack is using the 3-gang junction box. Mine fits in a 2-gang box, but this little plate adapter I put together is the same sheen and the same ABS plastic as my detector enclosure, and it allows you not to have to, take the 3-gang junction box out of the wall. I can hide it. So just a little accessory, and I sold like 200 of these old things already. One other thing I have here too is we do have a handheld device for calibration. I can send you some specifications on this as well. With this device in the field, it allows you to daisy chain the communications. So this will allow you to set up and see all of the detectors currently via the Modbus. This again will turn to BACnet shortly. This is a very handy device. You can rescale your alarm thresholds. We've limited it to just kind of resetting alarm points and sensitivity. But it's a really handy device to have in the field. Less than $200, and I'm typically selling 1 or 2 of these with each of the orders that are being placed. What else?
Hey, Bill, do you have a sample submittal maybe you can pull up on your shared screen there that we can look at while you talk through this? Or I'd recommend just stop sharing your screen and make yourself bigger.
Yeah, I do. I do have a brochure and an installation and operation maintenance manual. There's one more thing I want to show you guys while I got this set up. Hopefully you can see this well. This is a 120 volt detector. This happens to be a Schneider Electric 8000 series controller. I distribute Schneider, so what I've set up here is a typical application. 120 volt detector, relays tied back to the building controller, and then once this reaches a pre-programmed set point, this will output. This happens to be a third-party interface for a Panasonic setup. From what I'm aware of, Panasonic's no longer selling VRF in the US. I did this 4 or 5 years ago, but I've got the relay outputs from the building controller tied to this third-party interface back to the VRF system to indicate an alarm, to basically get the people out of the room and try to isolate the problem. The way we do a function test is with a magnet that comes with every device. Every one we sell has a magnet in it. I just put this on the end of a pen, but you can see the green LED shows proper operation. It's the detector is operating. I could take this magnet, put it on the other indentation on the front faceplate, and this will do it goes through the cycle. It goes through the cycle. It closes the relays, sounds the beeper, and then resets. 5 seconds just to check the continuity of the relay outputs and the beeper. 5 seconds it takes to do that. No real regular calibration. We suggest a bump test every year or two, just to go in and give the sensor head some gas, let it actuate. It takes a little while for the gas to clear the sensor head, but pretty simple. No regular calibration required. You don't have to set it up. You guys still with me?
Yep. This is all great. Couple questions.
Certainly.
Compatible with any manufacturer of VRF?
Oh yeah. Yeah, I don't see any issues there. I have 2 versions available. The low voltage, I've got a 12 to 24 volt AC DC, and then the line voltage is 90 to 240 volts AC. What I have found over the last couple of years of being involved in this is I have some people. I had a group from Siemens call me with the thought of using the low voltage and dumping it into the security system. DC voltage is typically continuous, and you've got continuous monitoring of those panels. Just a thought. Most of them are going up to the building management system, but in my mind, it's worth considering the security side too. Those panels are constantly monitored, whereas the building management, I've been in a lot of building managers' room, sometimes yeah, sometimes not. Another question?
Yeah, we got a handful of them coming in.
I love it.
There's another one. Looks like there's some interest from the Mitsubishi side. Can it talk directly through the Mitsubishi backnet controller, or does it require a separate one?
That's a good question. If once it has the backnet output, I would assume that it is absolutely integratable. Why not? Why wouldn't it be?
So it uses its own controller and not a separate one?
That's, well, at least the output. It's not really a controller. It's a dumb device. It only does one thing. It's sniffing for a target gas, and then when it sees it, it closes relays. So it's really, the detector itself is pretty, it's pretty simple. In terms of what it does, it's either off or on. There's no middle ground. And I just see the backnet option as bringing that up to the front end. Again, the building management office, just to indicate an alarm on their screen. I'm not sure I answered that properly, but
I think that's good. If you want to dig further into that, Fergus, please reach out and we'll get you situated on that. Another question coming in is there typically a local audio alarm to get occupants out immediately when there's a higher detected ppm?
Yeah, at 2,000 parts per million, it sets off a 76 decibel beeper, which I just kind of showed in a reset there. So it'll beep constantly. And again, I see the use of the room controller here as an additional step to this. Doesn't have to be the Schneider one I'm using. Honeywell's got some pretty sophisticated stuff. Siemens has some good controllers out there. But to me, putting a visual indication on that faceplate of that room controller makes a heck of a lot of sense. A beeper going off is gonna wake people up and make them wonder what's going on. If they see a red indication up on the wall along with that beeper, it's going to motivate them more. After all, the bottom line is to let these people know there's a problem in the room and they need to evacuate. I hate saying that. Hilton cringes, in that situation. But that's what we're doing. We're indicating a problem and moving the people out of the problem area. It's pretty simple.
I also just want to mention to everyone in this webinar that under the handouts section, there is some, looks like we dropped in a submittal and an installation manual if you guys want to see those and download those. Another question, is there a minimum/maximum distance between the emitter and the detector?
I'm not sure I understand that.
Is there any limitations on the length of wiring?
Oh, heck no. No,
okay.
Not at all.
And then there's another question's about how many are we installing? You're typically seeing these installed in every single room in a hotel application?
Yeah, the first two jobs I did were a good example. We were just in Atlanta for ASHRAE. My first installation was with a hotel, a Thompson Hotel in Buckhead. When I was in Atlanta just a couple of weeks ago, I stayed not far from that hotel. It was a 280 room new construction, and they have detectors installed in every one of the rooms. They did a great job on the installation. I've had another installation down south that didn't seem to be following too much in the way of electrical code or doing any just not following any good practice. Okay, but the installation in Buckhead went very well. Thompson Hotel is a high-end division, a luxury division of Hyatt, and they were very pleased. 280 rooms installed properly. I've had no issues at all. I know they've been around, giving them bump tests and basically put the magnet on the front faceplate to make sure it's operating. It's a it's simple maintenance. It's the people coming in changing the bed could do that. Really, that may be pushing it a little, but you understand.
Perfect. I think we're pretty much caught up. Oh, do the VRF installations have to comply with the ASHRAE standards 15?
I haven't seen a whole lot of direction from that, but I really believe at some point that this should be mandatory. It's really clear that there's a hazard here, and it's better to have more protection than not enough in my world. I think anybody installing of these VRF systems understand that. I have a guy out in the Midwest that I've known for a while. He actually is a Mitsubishi installer. And this is a guy I started talking to, I don't know, 5 or 6 years ago when I was just starting on this project and trying to educate myself on what was going on in the field. He happened to be doing a lot of residential installations with a couple different companies, a couple different VRF suppliers. And he's aware, in his words, he's aware of hundreds of leaks in the discharge coils. Mostly residential is what he's doing. So to me, it's not just the commercial market. It's not just big hotels. They are using this technology now in homes. And I see that as a whole nother part, a whole nother segment of this.
Perfect. There's a couple other questions on the placement of this in ASHRAE 15. So in terms of achieving ASHRAE 15 compliance while minimizing costs, can these be installed exclusively in rooms where there are ASHRAE 15 violations? In other words, can you not put these in every single room to minimize costs?
Well, the thing is, you'd want them in every room. Each room is an enclosed, is a separate enclosed space, at least in a hotel. What I'm finding now is classrooms are becoming a point of reference. I have people now concerned about kids in classrooms, mounting 2 or 3 detectors, depending the size of the room. That makes a lot of sense to me. There's other applications that I'm seeing, stuff that I hadn't really thought about previously. But this is an open market. Wherever they're using these systems, the chance of a leak is there, whether it happens or not. And to me, that speaks to ASHRAE 15. I feel like I've tried to comply with what ASHRAE 15 is saying in a device that is very stable and is going to give you, and the other part of it is looking for the target gas. We're not looking at oxygen reduction potential or anything outside the target gas. If you want to indicate a problem with the gas, it's always good to maybe sense for that gas. It sounds kind of goofy, but to me, that means a lot. We're looking for the target gas. We're not looking for anything else. That's all it's looking for.
Perfect. Totally agree. Can we talk about wiring requirements?
Pretty simple. 3-wire. I've got 3 terminals, 120 volts, and then just a couple relay outputs. The voltage, not 90 to 240, or the low voltage. I've got the 12 to 24 AC or DC. But I haven't had too many, issues in terms of wiring. 120 volts, is a kind of standard application, and I'm comfortable with the approvals and everything here. One thing I do want to mention to you guys that has come up, The detector that I've developed is manufactured in Italy. It carries the CE mark for electrical testing and continuity. The CE certification on this detector, first of all, the company I'm dealing with is ATEX certified. They do gas detection across the board. This is a really well-run and certified company that I'm dealing with. So if that kind of requirement comes up, I believe this passes anything, any UL electrical standard. It's substantially better. I've had some blowback that it doesn't have UL. UL in this country anymore, everybody that works for UL has the word sales in their title. These guys, to try to get UL certification for this detector, cost me $100,000 and 35 detectors. I don't believe we need it, but I'm being open and honest with you guys. Some people are balking at that, but this detector is the best built solution for the application, period.
Perfect. Questions on, does this detector shut down? Does it have a solenoid valve that shuts down anything? Does it turn off anything, or is it just an alarm?
It's literally an indication of a problem. To dig deeper into this issue, because you've got, if you think about the standard VRF installations, it is a central feed line that goes out on multiple branches, high tonnage and high pressure. This gentleman that I mentioned out in the Midwest worked with a couple other engineers, and they have developed and patented a system that can isolate one fan coil. I'm not quite sure engineering wise why it's currently can't be done, but there's the system has some kind of an issue where you cannot just isolate one fan coil. These guys worked for 2 years to come up with a solution, and he has it patented. The problem with him and his group is they have the solution, but they don't have money to bring it to market. They're looking for investors to bring it to the market. So I throw that out to this group. That's really interesting. A patented solution, and I have some detail that they put together for me. I kind of was watching his progression on this, and a pretty sharp guy. 2-3 engineers have come up with a good solution. Anybody wants to talk about that, I can throw you some detail. He's given me some specs, but to me, indicating a problem is one thing. Solving the problem is really what needs to be done. All I'm doing is waking somebody up out of bed, telling them to get the hell out of the room, as opposed to solving a problem. There's only one person in the country that I'm aware of that has a solution for that. I may be wrong there, and would think other people are working on it. I don't understand the full engineering or what the problem is with that, but yeah, it's a problem. They can't isolate one fan coil.
Okay. Yep. There's another question. How does the occupant know to leave the space? Once again, there's going to be a very loud alarm that will sound to alert people to get out.
Correct. And again, I want to see this coupled to the room controller. That's really the smartest thing for the occupants of the room. Schneider Electric, thing's expensive as hell, $400 for a damn thermostat, but it's functional as hell too. It does a lot. You want the visual indication, you want the beeper, but that's just an extra added thing in my mind. If someone wakes up out of bed hearing a beeper and they look over on the wall and they see the wall controller flashing, that's going to get somebody up and out of bed and in the hallway. My just one man's opinion anyway.
Yeah, exactly. Has this been approved by main hotel developers? I mean, you mentioned Hilton. Has this been approved by others as well?
Well, I've got two. I've got 2 Hyatt installations. I'm hoping that I get some more from those guys in the Southeast. Not really. I haven't, it's a hard thing. I have contact with Hilton out here, a gentleman that is head of engineering for the West Coast, and I've approached him a couple times. Have not had much success, starting a conversation with him. What I am finding is the VRF manufacturers out here, the guys that are supporting the installations, the VRF distributors, and also the mechanical contractors that are doing the installations. That's where my business is starting to come from, and not just here, all over the country. I'm getting calls all over the place, down into Mexico as well.
Great. Yeah, that's wonderful. I think we've covered most of them, but I do want to, if you can touch on just, rough budget costs. You don't have to go into details, but just a rough budget cost for some of these engineers involved.
No, absolutely. I'm trying to, I want to be competitive here. I see Backrack selling their unit. I saw they were selling it on the Keeley side. If you know Keeley, kind of a southeastern distributor, they're selling them for $500 online. I'm trying to be competitive for small quantities is a different matter, but all the projects that I've run into at this point have been anywhere between, say 150 units and 350 or 400 units. So we're not just selling one or two of these things. I'm trying to keep the cost to the people on this call as low as possible. It's under $300 is what I'll tell you. Depends on quantity, but under $300 net, your net. I have a little bit of leeway on quantity breaks when you get into the 1,000 and 2,000 units. I can offer a couple additional points on the net. So.
Perfect. I believe we've gotten to all the questions. If I missed anything, I apologize. Is there anything you want to touch on before we start to wrap up?
Well, one thing I'd like to say is I want to thank everybody on the call here. At some point, it looks like there were 60 or so people listening in. That's a record for me. That is a total record. I've done some big presentations. I've done some presentations for ASHRAE out here. I did the Orange Empire ASHRAE monthly meeting a few months ago, and had about 40 guys show up just to hear about the detector and the nature of the just the VRF application in general. So this is a record breaker, fellas. It's the biggest group of people that have listened. I am happy to answer questions that you guys have. One thing we haven't talked about that I'd like to hit on real quick is just supply chain stuff. We have run into some minor problems, but I'm still in a 6 to 8 week window in terms of delivery. Typically in my world, and hopefully in yours as well, that new construction is being planned ahead of time. To me, 6 to 8 weeks should be a reasonable lead time. Hell of a lot better than 26. That's for sure. I'm a Backrack distributor too. I can't imagine having to tell somebody that.
Right. Well, perfect. Okay, perfect. Well, thank you, Bill. We appreciate your time. If there's any questions that we didn't get to, or if you have any other questions, please do not hesitate to reach out.